Johnson, we need to turn in 106.
For next class.
Next class, okay.
Look forward. Oh.
That's how it kind of is. It's called the college papers for Indiana. But then you take super hard classes your freshman year so that they can weed out people that don't belong. But really, the math there is really hard. But it's all in finance, so I don't understand how that goes.
One on
We'll see, I
that.
guess.
That's for not that many.
Oh, and what? And then you can brush it out of your head, yeah. Okay. Those. Yeah. I have no idea. I have no idea. I don't think they make you pick a major and then it's a little bit like past. Good morning. Did you turn in 107? You didn't do it?
And they said, I was
Is it due?
Is it? I saw.
I don't think so.
No
That
way.
thing says
I woke up
106 is
and
due
was like,
next
so
class.
well, yeah, like, it's.
I don't think so. Which is so good.
It does say that, yes.
I woke up early for
All
no
my
reason.
numbers are
Dang.
So unfortunate.
I didn't know what it was.
I didn't. Okay, so I did like 106. No,
I
107.
didn't understand it, but I did it. So.
Yeah.
I was like, what's doing it?
What does it look like? I just can't do it.
I have like,
No, I got 0 on like
yes.
multiple, which is not right.
I'm sorry. I just ordered. I watched the first order. Yeah, I just did reviews off of Amazon. And okay, I want to get a 5 on them. I never ever. 3. I'm gonna get a 5 on environmental science.
They live in Northwest
Washington. I'm so excited for this. Yeah.
But I'm not asking you to answer one of them yet. So you got I'll have more than one day. That's fine.
I know, it's probably like next to an A.
Gary,
Thompson, are you taking lit next year?
Yeah, I think so. Is it hard? What?
Are you good at reading it?
I mean, pretty good. Not amazing.
It's so boring.
Okay.
This math is so fun
And she did. So it's more in a way.
the whole time?
though. She's like a fun teacher. The class is really boring.
Oh,
And
I
it's
got
all
you.
like, it's like Hamlet and stuff, so it's like old English. It's terrible. Lots of reading.
Is she the only teacher? Or?
Yeah.
Okay.
Yeah.
Well, I don't mind reading, so it's fine. But like writing essays.
It's a struggle.
Yeah.
She's a hard teacher.
You got any other teacher reviews while you're at it?
I gave you a 10 out of 10 or something.
That's only because I'm here listening to you.
No.
you give Stuart last year?
No, I have Mr. Ballinger.
Oh.
I had Stuart. He was
So you still get that easier?
yes, but like, I still think, do you think she's a harsher grader than Stuart? Miss Mathis. Yeah.
Oh.
It's just different than AppLab. Like, I don't
Yeah.
know, the essays in AppLab are like easy, but these are like, but you have to do like poetry analysis and stuff, so that's really difficult.
It'll be fine.
You'll be fine.
Yeah.
How many other exams are you taking?
Next year, I think I'm gonna take Fuller.
That's what I did, and then I dropped it. 'Cause I was
Good
like,
morning,
I wanna
FHS.
take
Today is Tuesday, March
Yeah.
26,
Yeah, I think I'm
2024.
gonna take
This is Senator Tyler.
Easy, yeah.
Wait, one more. I'm trying to think.
Psych. What are you taking, psych?
I'm not gonna take that. I wish I would. But
You should.
oh, micro.
Oh, that's
Just like-
fine.
Sorry.
I've heard that one's like really hard.
It's Galley teaching you.
He does? Oh, nice. I'm not too bad. What do you think?
That's the easy part.
Yeah, like the exams like writing essays, but it's answering some multiple choice, but like in class you kind of just read some books. Honestly in class like, we don't kind of do random stuff. Not like random stuff, but like it's not super it's not
That you are able to join in with
oh, we did do reading.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Yeah, I would just make
Have a great
sure.
day.
All right, guys. Good morning. Welcome back. Let's get started, please. I got a couple small announcements here that I want to mention to you a couple times since it's going to be a little bit different here. One thing under the homework, I do have an assignment that you guys did 2 days before the spring break that I'm just now asking you to turn in. So that is 106 and it's listed under the homework. Just make sure that you notice that and have that turned into Google Classroom by Thursday. Also, since we are just really a handful of days, class days, till your AP exam, we'll have quite a few small quizzes starting with next class, and so I'll always warn you what those are. And so that's over here under upcoming assignments. So it'll be just 1 to 5 questions, 1 to 5 points. I tell you which assignment you might want to look back at, number 78 in your binder. So the one on Thursday, again, just 1 to 5 questions, 1 to 5 points, just small. This is something you're supposed to already know, but I do want you to spend a couple minutes reviewing it, and the reward should be a couple easy points. Doing it that way, I think, helps kind of break up some of the stuff that you need to know for the AP exam, and then it's not so much of make sure that you still remember how to do this packet of stuff a week before your AP exam, and it's not doable. Now, 1 to 5 points doesn't sound like a lot, but I do count those as major points, as assessment points. And even 1 to 5 assessment points or major points is not that much. But again, I'm going to do a bunch of these leading up to the AP exam, so they will add up over time. So all you really need to do is just make sure you look over that stuff. And if you have forgotten it, make sure you relearn it, because now's the time. You're running out of time to do that kind of stuff. I can't promise to do this on everyone, but I also posted on Google Classroom yesterday 2 Khan Academy assignments, and some of the questions that I use on the quiz actually come straight from those. So if you know you want extra practice, I linked them on Google Classroom, and if you're willing to do that extra practice, you may actually try the question that you end up seeing on your quiz anyway, so there's that benefit. I will remind you of that before the end of class, but since that's a little bit different than you're used to, I wanted to mention it a few times to start off class with that. All right, we are in the very last unit. We've got just a handful of new things we need to look at before we can focus solely on AP review. So 2 of the things that we did before the break was L'Hopital's rule. That's the assignment I'm asking you to turn in before Thursday. It should already be finished. Area between two curves, which I will still ask for, but you don't have to worry about it between now and Thursday at least. And then we've got two more that we're going to look at today. Volume of revolutions, something called a disk method. So I'm going to go over those notes, talk about that process, then give you about 15 minutes to try one Khan Academy on that. And then finished or not, we'll do the second set of notes, which is something called the washer method, which is really just the disk method twice with subtraction. And then I'll give you some time to finish that up as well. So these are two more of the last couple topics that you need to know. Now, you do want to make sure you give me your full attention here, because I don't think these are that difficult, but I will say that some students feel like they have a harder time catching on to this sometimes. So before I tell you what we're doing, let me first remind you how integration worked and how we used it so far this semester. So if I integrated from a to b of this function, what does this find? What is this telling me?
The area between it and the x-axis.
Right, so the area under the curve to the x-axis, right? Now, remember why this works the way that it works. What it's really doing is it's taking an infinite number of infinitely thin rectangles, right? Adds up an infinite number of rectangles. Now, you probably don't normally think of it this way, but this is like the length of each rectangle, the y value to the function, and this is like the width. But again, the width is infinitely small, but dx is how we do that. Okay, so with that in mind, integration adds up an infinite number of rectangles. Well, it can actually add up an infinite number of any type of shape. So what we're going to do in this unit is we're going to take a two-dimensional shape like this, and we are going to spin this around either the x or y axis today. We'll look at other lines on Thursday. And then this two-dimensional shape rotates around three-dimensionally. And what you end up having is a three-dimensional shape that with just a tiny bit of calculus, we can find the volume of. And of course, this is not a shape that just fits some geometry formula where you can just plug in a couple numbers, hit enter on your calculator, and you've got the volume. This curvature makes it require some calculus. Now, what this has to do with integration, and why I was bringing up the area part, is integration can mean add up an infinite number of anything. So, when I take this point and spin it around, and if I take this point and spin it around, if I take all of the points on this function and spin it around, again, it ends up looking like this. Of course, their picture looks a little bit better. But I'm creating an infinite number of what shape? Right, so we are now going to use integration, and this is why it's called the disk method, because a disk is basically a circle. We want to add up an infinite number of circles. Well, the formula for area of a circle is pi r squared. So we're going to integrate pi r squared, and we are just going to have to be careful about what r is, because r is going to be changing. Sometimes r could be less or a little bit bigger or even a little bit more. R is going to be in terms of x if this is dx. So every one of these, for disk and washer, we're going to be integrating pi r squared. Okay, so let me give you one example before I have you try it, and you're going to see why you want these pictures. On the Khan Academy, I think they provide pictures for you on most of them, but just get yourself a decent looking picture here. Now, most of this setup is actually pretty easy, at least in my opinion, because it's very consistent. Every question is going to be doing the same thing. But we need to find the area trapped in between these two functions. So that's a two-dimensional area. This 2D area is what we're going to spin either around the X or Y axis. Now, you guys don't have to make a habit out of drawing this, but this is a very common math thing. It's to draw a little circle there to show which axis we're spinning it around. So if I take this flat surface and spin it three-dimensionally, it's going to create a three-dimensional shape. A three-dimensional shape that doesn't match any of our geometry formulas, but with integration we can still do this. So when we integrate this, because we're spinning it around the x-axis, you need it to be dx. When we spin it around the y-axis, it's going to be dy. If you're spinning it around the x-axis, you need to find the far left and far right intersection points. So sometimes your graph is going to show that to you. This one, not so much. But you could always set these two things equal to each other. If this equals y and this equals y, then they have to equal themselves as well. But if you're spinning it along the x-axis, you need x values for your limits of integration. When you're spinning it around the y-axis, you would want y values. So it would be the smallest or the bottom number to the top number when we do around the y-axis. And then the last part for the disk method is to understand that when I spin this, now again I apologize, my pictures are pretty bad here, but this is where the picture is going to help you. If I take this point and spin it, it's going to create a pretty small circle. Over here it would be a little bit bigger. Right here would create the biggest circle. But I'm creating an infinite number of circles, so it's going to be pi r squared. And really the only part that takes a lot of thought, because again, a lot of the rest of this is just going to be consistent with every question, so that'll get easy to you after a few. The part that can be challenging though is you need to determine what r is. R is usually not just a number. And again, this is where the picture kind of helps. This distance is r, this distance is r, and this distance is r. R is changing, so it's not just going to be a number. But what do we normally call the distance from the x-axis to the function, x-axis to the function, x-axis to the function? What do we normally call this length? The y, and specifically it's the y value for this function. So those lengths are whatever x squared minus 3 is. Now, one tip I can give you to make sure that you're setting this up correctly. If this is dx, that means this stuff needs to be x's. When we do dy in a little bit, this stuff needs to be y's. The variables need to match here. So we're not going to really focus on doing any actual integration today. I think most of the Khan Academy questions they're like multiple choice and you just pick out the one that's set up correctly like this. But the ones that are not that way, I'm fine with you just having your calculator integrate them. So we're really just focused on setting them up. Okay, so think about how I got the bounds, think about why I put dx, think about why there's a pi r squared, and specifically the hardest part, how did I come up with that as an r? I would like you to try that just one time before I go over it with you on number 2. So try number 2 and see how much of that you can piece together with just one example. Again, I'm not expecting you to feel like this is super comfortable already. I just want you to kind of piece together what parts you understand where they came from. Okay, so again, maybe at some point you're gonna, even if you're not finished here, let's go ahead and try to get you over the hump wherever you got stuck. Even if some point you don't feel like you need a picture, I really think a picture at first helps you see what the radius length is gonna be, and that's the hardest part. So y equals 0, negative x squared plus 4, so this would be x squared reflected over the x-axis and shifted up 4. So the area that's trapped in between these is this. This is the 2D area that you are trying to rotate around the x-axis. So the parts that should be very quick is you should understand we're just integrating a bunch of circles. So pi r squared. Because we're rotating it around the x-axis, it's going to be dx, and the limits are going to be x values. So again, you can always set these two equal to each other and solve if your picture doesn't show it to you. And this one, I think it's pretty clear that it goes through -2 and 2. Obviously a better picture. And then the only part that you should be slowing down and trying to be careful on is the radius. The rest of this should come together pretty quickly after a few examples. So I would recommend that you draw in a few circles. If I took this point and rotated around the x-axis, it would look roughly like this. Over here, roughly like this. This point's the furthest away, so it's going to have the biggest radius. But the point of drawing in a couple circles is it helps you see that this is the radius, and this is the radius, and this is the radius. And the distance from the x-axis to a function is what we call y. And y for that function was negative x squared plus 4. So this integration, again, I'm not worried about the integrating today, just the setting up today. But if we integrated that, we would know exactly how much volume that three-dimensional shape would be. Okay, so of course there'll be more time for questions later, but do you guys see any quick questions about spinning it around the x-axis? Okay, then spinning it around the y-axis. Sorry, there's a little typo on here too. I need to change this, but this is called the disk method, and down here this is the disk method. We'll talk about the washer method on the next page. Okay, but I think you can probably guess what some of the changes are going to be based on how I emphasize the other one. So we want to do, these are supposed to say x equals 0. Where x equals 0, where y equals 0, and where negative x plus 8. So those three functions trap in some area, but since we are rotating around the y-axis this time, that's going to change a couple things. First off, we need dy. Second off, our limits of integration need to be y values, the smallest y value to the biggest y value. Now this is not a great example because if you did x values, you would accidentally get it right on this question, but dy, smallest y to biggest y. We are still going to be adding up an infinite number of circles, so it's still pi r squared. You can still use your picture to visualize a couple of these. So if I'm rotating it this way, this point would turn about that much, about this much. The biggest one would be about that much. But sketching in a couple of circles helps you see that this distance is r, this distance is r, and this distance is r. So what do we normally call the distance from the y-axis to a function? Right. This is x, this is a different x, this is a different x, but all of these are x to this function. So you might be tempted to say, let me plug in negative x plus 8. The problem is, remember, these variables need to match. It doesn't make sense for this stuff to be x's and this to say dy. So we can take this function and we can solve him for x. X, which is always the radius, is the same thing as 8 minus y. And the reason why I need to say 8 minus y is because I needed it to be in terms of y, because this was a dy. So again, your circles would be drawn differently. Your limits of integration come from y values instead of x values. It's dy instead of dx. But otherwise, it's pretty similar to rotating around the x-axis. Okay, so if you would, try that for me one time on question 4. Hopefully we can at least identify one part of what might not be clicking right away. Okay, so even without the picture, I can do quite a bit of this. Rotating around the y-axis, I know it's going to be 1 with dy. I know I'm just adding up an infinite number of circles, so pi r squared. Potentially, you could think about where the smallest and biggest y values would be, but you also not going to hurt you to sketch a picture, especially if the functions are nice enough. So x equals 0, and y equals 0, and x minus 5. So the correct area that we're going to rotate was this. We are rotating it around this axis. So now I can see it goes from -5 to 0. Again, you could have also gotten that doing algebra, but the picture kind of helps me with R anyway. Maybe sketch in a couple of these points rotated around the y-axis to see a few of the circles created, so that you can see this is R, and this is R, and this is R. That distance is what we normally call x to this function. Now, you might be tempted to say this, but how should you know this is a red flag and something's wrong with that? Right, you need these variables to match up. If this guy says dy, this stuff needs to be in terms of y. So don't say x minus 5. solve this for x. The radius is always x, and x is always y plus 5. Okay, so same thing. Any quick clarification you'd like to get from those two examples? Okay, so let me warn you, the next part, so I want you guys to move on, and I'm going to give you 20 minutes for this first Khan Academy, which is going to be too much time for some of you and not enough time for others. But I've got to pick something, and then after 20 minutes, we will talk about the washer method. But in case you didn't hear me say this at the start of class, the washer method is like doing the disk method twice and subtracting them. So the disk method is a little more important. So now, if the 20 minutes ends up not being enough, you'll have a little more time at the end of class to work on it. Now, I did assign 2 of them to you. Make sure you pick the one that says disk method, not washer method. We haven't talked about how to do the washer method yet. But you actually might be able to guess how to do the washer method with the hints I gave you. So I guess if you finish the disk method and you want to try one washer question, you're welcome to, but don't feel like you need to. Of course, if you guys miss one, you're more than welcome to click the start over button. But I would prefer you to click start over than to just guess as a way to reset. I do look at the questions that y'all missed the most, and try to figure out if it's one we need to look at some other time. So that's why I would prefer you not to guess on any, because it kind of skews that data a little bit. And again, in case you didn't hear me, I'm not asking you to try to integrate anything by hand today. Feel free to throw it in the calculator on the ones that are not multiple choice. Also be careful though that I think most of them, if not all of them, that actually want you to put the integration in the calculator ask for your answer to be in terms of pi. So you should not put pi in your calculator, but you should leave pi in your answer. And of course, if you don't do that, then like if the answer is 5 pi and you just say 5, those are two totally different things that's going to count it wrong. I can see some of you already finished, but again, I'm giving everybody 20 minutes, which is about 11 more minutes from now. So I'm just pointing that out to you because if you're already finished, I would prefer you not to sit there bored. You could make sure you had that homework turned in, or you could look back at 78 for the mini quiz next class, and that would be a good use of your time. Just suggestions, though. move on in about 5 minutes. Go ahead and finish your thought. Again, if you're not finished, you'll have some more time. But for now, we will move on. So I'll give you a second to finish up what you're thinking about, but don't start another question yet. Okay, so the second half of this, the washer method, again, you cannot do the washer method if you can't do the disc method. So in a minute, if you're still not finished with the disc method, you should really stick with that one first. But to me, the logic behind the difference between disc method and washer method is really the same logic behind the area between two curves like we did before spring break. We know that if we integrate f of x from a to b, that gives us the area under f of x to the x-axis. And then if there's a second function, if we integrated g of x from a to b, it would give us the area in purple here. And the area between two curve stuff, if we know how much red area there is, and we know how much purple area there is, we simply need to find the area between those by subtracting them. So the idea is, by taking the red area, it's a little bit too much, so we're going to take away how much is too much, which happens to be the purple area. Now we're going to do the same thing, but in 3 dimensions. So we've got a big overall shape, like this, that we can find using the disc method. That would give me the volume of the overall shape, but some of this is not filled in. The stuff that's not filled in is this. So we can do the disc method a second time, and if I know how much the full shape would be, call that blue. If I know how much blue volume there is, would be the whole thing if it was filled in, and I know how much red volume there is, how much volume is missing, I can just subtract those and then get the actual volume of the stuff that's around that hole inside the shape. So similar to the other notes, I'm going to do one around the x-axis and one around the y-axis for you, and have you try one of each before I go over it. So on this one, I'm going to start off around the y-axis this time. So same thing, I do think a picture helps. Of course, over time, you're welcome to move away from that, but a lot of times pictures are provided to you anyway. So we need a y equals 0. Also, these graphs can be a little bit messier, so you really want to probably try to make your graph as big as possible. I've got 3x minus 9, and I've got an x equals 1. So immediately, and this is spinning around the y-axis, immediately what's a little bit different about this picture that makes it a washer method instead of a disc method is that I'm trying to spin this 2D area around the y-axis, and directly next to the y-axis it's missing some area, which means when I rotate this it's going to be missing some volume. So we have to come back and subtract how much volume is missing, which makes it the washer method instead of the disc method. Now when I say washer, you guys know what a washer is? Like when you build furniture and stuff? Okay. That's what these little cross sections look like. They look like little washers. That's where it gets its name from. Okay, so if I'm going to rotate this around the y-axis, I know it is going to be dy. I need to do from the smallest to the biggest. So what would be the biggest y value that I'm interested in? 0. Okay, and then the smallest down here at, you think maybe -9? -9 is not where there's no area from -6 to -9. So when I rotate, there's not going to be any volume that far either. So you need to be careful. This actually only goes to -6. We only care about where this area is trapped. So -9 is all the way down here, and again, from -6 to -9, there's not going to be any volume because there's not any area. So that's an easy one to miss there. Now I'm just going to worry about the big outside shape first. So that's going to be referred to as big R, the big radius. So same idea, you can take a point, rotate it around that axis so you can kind of see one of the cross sections, maybe a second one if it helps, maybe a third one if it helps. But I can see this distance is X, this distance is X, this distance is X, and specifically it's X to that function, y equals 3x minus 9. Now since this says dy, I can't put 3x minus 9, I need those variables to match. So I could add the 9 over and divide both sides by 3. I would say the big radius is 1/3, well, you could write that lots of ways. 1/3 y plus 3. Okay, now we're still doing circles, so it's still pi r squared, but to me this represents the overall shape. If there was no gap in volume, this would be all that I need. But there is going to be a gap in volume because there's a gap in area. So I'm still going to be integrating dy, still negative 6 to 6, still going to be circles, pi r squared, and this is usually referred to as little r. Big R, big radius, little r, little radius. So again, this helps where your pictures are a little bit bigger. But in here, when I rotate this is going to create the gap in volume because of this gap in area. So you can draw in a couple of those cross sections and it turns out that these are always the same. It's not always in terms of x or y. This radius is 1, 1, 1, 1, 1. No matter any cross section you draw, the small radius was 1. Now, I would actually prefer you not to write it like this. In fact, there's a lot of, I guess you would still get the points, but when we look at some practice FRQs, usually it's going to be formatted this way. This stuff is true about both of these, but usually they like to see that you just do it as big R squared minus little r squared. We can combine these two integrations into one single integration. Just put a minus sign in between there. And of course, 1 squared, you could just say that's 1. You don't have to leave that 1 squared. But you need to think of it as big R squared minus little r squared. And don't forget pi, because area of a circle is pi r squared. Okay, so that, again, it's really like I did the disk method for the overall shape. I did the disk method for the shape that was missing, and then I subtracted those to get the volume of the shape that was still there. Pi, integrate big R squared minus little r squared. Okay, so I'd like you to try that with question 2, please. See how close you can get. This one's also around the y-axis. Again, it's a very complicated looking statement, but about half of that is pretty expectant. Okay, so finished or not, you should at least see where you're slowing down. So, looking at my picture here, I went ahead and graphed those and highlighted the area trapped by all three of these. So it's not this area, because this area wasn't trapped by y equals 9. You got to make sure it's trapped in all three of those. Since there is area missing next to the axis I'm spinning it around, when I spin this around 3D, it's going to create a hole in the shape. And that's how I know it's washer method instead of disk method. So again, I'm going to just do this as one big integral dy, because we spun it around the y-axis, pi big R squared minus little r squared. Of course, these are the two tricky parts. You could either do algebraically or with your graph carefully. It looks like the smallest y value is 4 and the biggest y value is 9. So from 4 to 9. Okay, and then in place of big R, that's going to be the big radius. So you would take a point on the far outside, spin it around the axis that it wants, and do that, I don't know, 1, 2, 3 times. Do it however many times you need to so that you can see this is the radius, this is the radius, this is the radius. They're different, so it's not going to just be a number. The distance from the y-axis to the right, distance from the y-axis to the right, distance from the y-axis to the right, we call that x, and that is on this function x squared. So if y equals x squared, x is the square root of y. And of course you could just change this to y, because squaring a square root would cancel, but I'm only pointing that out in a multiple choice. If this just said y and it wasn't squared anymore, that would be equivalent. Okay, so that's the big R. And okay, I was trying to get this stuff out of the way, but sorry about that. Okay, I think that's close enough. Okay, so this was square root of y. I erased that. Okay, and then the little r, you would take an inside point of the area, rotate it around the y-axis, rotate it around the y-axis. In this case, they all look the same. The radius is 2, the radius is 2, the radius is 2, the radius is 2. So small r was 2. Or of course you could replace this with 4. Now don't forget the pi, but you can do it as one big statement like that. Okay, so any quick questions that you want clarified about 1 or 2? Those are the only two we're looking at for y-axis. Yeah.
Can you show how to find the values for algebraically with me?
Sure. So since I know this one, okay, so you're gonna have to think about, if we're spinning it around the y-axis, we need y values. So these two are going to intersect at one time. So if I solve this for x, it would be equal to that. And then also, well, maybe that's not the best way to think of that. I'm thinking of it, if I plug 2 into this, then y would be 4. So when x equals 2 and y equals x squared, they're going to be at the same place at the same time right here. Okay, and then the upper bound would be when these two are in the same place at the same time. But since I want y values, this one already tells me what y is. So that would be up here, and that's where the 9 comes from. So it's not a very interesting Algebra 1, but the other problem with the algebra though is like I still think the picture kind of helps you see that it's like these two are the upper limit, so thinking about where these two are touching, and these two are the bottom limit, which two x equals 2 and y equals x squared. So I still think there's benefit in the picture even if you practice it with algebraic. Okay, so now let's do it with x-axis. So again, I think you're probably not going to have many surprises here, but this is, of course, another piece of this. So I hope you've done enough pictures here that you can see that the bigger and clearer your picture is, the easier it is to pick out the R values. So be extra careful there. But we've got a 3x minus 9, we've got a x equals 3, and a y equals negative 3. Again, even though I tried to make my picture pretty big here, actually, you know what, I'm going to just cheat a little bit. I'm going to just look at these two quadrants. Okay, that didn't do a lot of good, but that area that intersects is pretty small. Okay, so now we're doing x-axis, so we're going to spin it this way. Notice there's some area directly next to the x-axis that's missing, so that means when we spin this, there's going to be some volume that's missing. That's how I know it's going to be a washer type problem instead of a disc type problem. So there's two radiuses I need to consider. Okay, the bounds look to be 2 and 3. Now I'm very sure about this one because this is x equals 3 and I can see that. So that's a little bit easier. This looks to be 2, but if I'm not sure, I know it's this line and this line that are touching. So I can plug negative 3 in for y, and then I can solve this. And sure enough, it is 2. That's what my picture looked like. I just wasn't 100% confident there. It could be close to 2. Okay, now this time, I know I can zoom in and that helps. But the big R is going to be by taking a point on the outside of the enclosed area and spinning it around the x-axis. This is going to make the biggest circle cross sections. So I can only draw in a couple here, but we can see that the radius is always going to be the same size. It's going to be this length, and that length happens to be 3. Now, does it really, I know I'm going down 3, but I'm not talking about negatives here. Why does it not matter if you did 3 or negative 3? Yeah, it's squared either way, so if you want to say negative 3, I guess you can, but it doesn't change anything. And notice the fact that this is squared, and this is squared, and this is supposed to be big R, and this is supposed to be little r. This should always be positive. We're only talking about positive volumes. There's, as far as I'm aware of, there's no such thing as negative volumes. Okay, and then so the small r is going to come from taking one of the inside points of the enclosed area and spinning it. And these certainly do change size, so those are not going to just be a number. But this distance from the x-axis down, this distance from the x-axis down, this distance from the x-axis down, we call that y, and it's y to this function. So again, you might be tempted to say y, but this is dx, so I need it in terms of x. You need to leave it 3x minus 9. So it's not always the little r that could just be a number. It could also be big R that's just a number. You have to keep up. It can change question by question. All right, and then finally, if you would do one more for me as guided practice. And then I'll give you a couple of reminders about what I need from you between now and Thursday. And then you should have, you're going to have almost 30 minutes to finish up those two Khan Academies. And those of you that finished up the first one only have one more to do. So now we will practice the same thing on Thursday, except the only difference on Thursday is instead of spinning it around the X or Y axis, we'll be spinning it around different lines, like Y equals 2 or X equals 4. But 99% of what we talked about today will carry over to those question types. So. Also, this is an A week, so I will not see you on Friday this week. And unless I miscounted there, if you include today, I think we have 17 classes together before your AP exam. So it's a good thing we're just about finished with new stuff. Okay, let me give you an extra minute here. I'm going to start drawing my graph though. Okay, so on this one, your picture and the area you should have been spinning is this. We are rotating it around the x-axis. And again, you don't have to draw this. Your AP College Board does not expect you to do that. But I would say one benefit that I haven't really thought of before is you might accidentally think this is the x-axis if you're not careful. So it's kind of nice to have a little reminder that the x-axis is what actually down there. The fact that the area that I'm spinning doesn't hug all the way up to the x-axis tells me there's some missing area. So when I spin this, there's going to be some missing volume. And so that's how I can quickly know I can't just do disk method. I need to do washer method. There's going to be some missing volume I have to subtract. So for big well, let's just go ahead and do the bounds. It looks to be 1. Yep, those are the same, and 1 to 2. So that was pretty easy, especially with the picture there. But the big bounds, or the big R, is where you should be taking points on the enclosed area furthest away from the axis you're rotating. And again, I think it helps if you draw in a couple of them so that you can see that this is the radius of each circle, which would be y to this function. So y is the same thing as x squared. Or you're welcome to put y there, just make sure you change it to what it's equal to, since this says dx. Okay, then the smaller r is going to be the points on the enclosed area closest to the axis you're rotating it around. So again, you can estimate those. You can see that they always have a radius of 1, no matter where you draw those cross sections. So small r is 1. Now, even though I'm sure you're not too worried about this at this point, when we do some practice FRQs, oftentimes they give a point, 2, or 3 just for being able to set this up correctly like this. That you did it in the format big R squared minus little r squared. Sometimes that you got the big R correct or small r correct, or that you got this whole thing correct. So they often do award a handful of points just for understanding how to set these up. Okay, is there anything you want clarification on before I let you move on? Yeah.
Could you say how you differentiate the big R and the little r when how you decided to do it?
Yeah, so it depends completely on what axis you're rotating it around. If you're rotating it around the x-axis, you need to pick the points furthest away. The points furthest away are going to have more to rotate. So I know that those create the big R, and the points on the enclosed axis closest to the axis you're rotating it around are going to create the smaller r. Now, if you're doing it around the other axis, it's a similar idea, but you want to take points on the far right, because those are furthest away from the axis you're spinning it on. Those are gonna, if they're the furthest away from the axis you're spinning it on, it's gonna create the biggest cross sections, so that's create the big R. Whereas the points on the enclosed area close to the axis you're spinning are gonna create smaller cross sections, so those make up the smaller R's.
Do these show up a lot on the AP exam?
I don't know if I could estimate a point value, but it is 100% going to be on the AP exam.
And it would be like no calculator, most likely. Or I guess it depends on the numbers they give.
Well, it could be exactly like the Khan Academies, where it's just multiple choice and you're just trying to pick out the one that's set up correctly. It could be on the calculator part where you would have to set it up, but then you could just let your calculator do the integration. When it's an FRQ, as I was saying, sometimes they will expect to see your work kind of in this format, and they might give you a couple points for this, just to set up, and then maybe one more point for doing it correctly. But more than likely, they're not going to give you one that's just like super insane to solve. Like, I'm not making you guys integrate this, but I mean, x squared is x to the 4th, 1 squared is 1. I mean, that's not the hardest integration to do by hand. So if they expect you to do that multiple choice, they probably wouldn't expect you to do that more than once or twice. But on free response, I guess they could have one more point hidden behind doing it. And the only reason I think they don't do it a lot as multiple choice is because they're testing separate things. If they want to test if you understand the logic for why this is set up the way it is, then it's going to be kind of like the Khan Academy's multiple choice, I think. If they want to see if you can integrate, then they're going to ask you to integrate. But there's not going to be a ton of times where they want to see, they better be able to set it up correctly and integrate it correctly. They don't need to test you on that several times to know if you can do that. So probably once or twice would be the max. Okay, so again, we're going to get to practice more of this next class, but for today and between Thursday, I need you to get more comfortable with it, especially picking out those R values. So if you did not finish the DISC method, Khan Academy, I would recommend that you stick with that one first, because if you can't do the DISC method, you certainly can't do it twice for the washer method. And then once you get 100 on that one, please move on to the washer method. And stick with that one, please, until you can get 100 on it also. Of course, if you don't finish with how much class time you have left, still got about 13, 14 minutes here. Please do that for homework or during advisory today. And then I started class with these 2 reminders, and I want to say them, verbalize them one more time, just as a reminder. Under homework, I do want you to turn in 106 in the Google Classroom. So again, that was homework 2 nights before spring break even started. So I know things before spring break are a little less organized, and I think we weren't in our classroom, our normal classroom and stuff, but if somehow you don't have that finished, you need to finish that to catch up to everybody else and get it turned in. If you wait till after the start of class on Thursday, it'll be late. I will also ask for the area between 2 curves, but I won't ask for that on Thursday. But again, if you didn't do that and you didn't do it before spring break like I suggested, and then you forgot about it or you didn't want to do it before you came back, then you're going to have to play catch up. But you don't have to worry about it by Thursday at least. So that's 1. Make sure that 106 is turned in. And then 2, your 1 to 5 question quiz, 1 to 5 major point quiz will be over just the second fundamental theorem of calculus. If you're not sure what that is, or if you remember how to do it, you might look at handout 78 like it's typed on the agenda page, and or you could practice the 2 Khan Academies where a lot of the questions came from that I linked in Google Classroom. Those Khan Academies are completely optional though. It's just that if you're not sure if you know how to do it and you want to practice, then I'm giving you the opportunity. And then, as I said, some of the questions came straight from that, so I feel like your reward for doing that optional practice is you might actually get to practice 1 or 2 of the exact questions on your quiz. So. All right, I think that's all I've got. So try to get done what you can here. You guys still have, I think I misspoke a minute ago, you still got 20 minutes. So.
understand what to do, but I need to solve because it's in terms of like the y-axis. So I need to solve this for x.
Okay.
So I would like square it,
Mm-hmm.
and then where did my word go? It would be like y squared minus 9, maybe. Right?
Squared both sides.
Then subtract the 9,
Okay.
and then square root to get rid of the x squared.
Okay. What about the negative though?
Oh. Maybe that's where I messed up.
Yeah, so you could square root, but then this would be still a negative x squared.
So I would multiply
or
by
a neg-
negative 1 before I would square root it.
No, you would square it first.
Okay. I'll just
Yeah.
can you write the steps out.
Okay. Tell me what you think you should do first.
Square.
Okay. So if we square it, it looks like this.
And then subtract the 9.
Okay, that's fine.
Multiply by negative 1.
Okay, good. I told you wrong because I was trying to look at the whole thing.
And then square root.
Okay.
And then you would plug that into this.
Okay.
And then that should be the answer.
Well, it wants you to actually integrate it. So throw all of this in the calculator. Don't
Okay.
put pi in your calculator. Figure out what this is equal to.
Mhm.
If this is equal to 7, then your answer is 7 pi. And then that's 7
Okay.
pi is what you should put in.
Okay, thank you.
Oh, sorry, I forgot to ask, did anybody have anything interesting happen over spring break? I feel like yesterday was so long I kind of forgot we just had spring break, to be honest. Nothing crazy happened to anybody that they want to share?
I mean, I met this guy from Madagascar, which is pretty cool.
Okay. Just randomly in Fayetteville, he was hanging out?
Well, we went on vacation to Costa Rica,
Okay.
and he was there, and he said he goes to a new country every month. So,
Must be nice. What's he do for work?
he said cybersecurity.
Oh, okay.
Yeah.
I got
I guess-
detained in customs. It was so scary. They thought my passport was fake. So they took me away from everyone and made me go into an interrogation room. And then we missed our flight and we had to spend the night in Charlotte. So it was very bad.
I mean, you do look a little suspicious, so.
Definitely. Yeah.
We went to Europe last summer, and I didn't get detained, but I get stopped every time, like, and frisked every time.
I always
I
get
don't
stopped
know.
and have my hands swapped down.
Yeah, they did that to me once, but
It's like a
I don't know.
Swap it. Yeah.
But one guy was like asking me like where I was coming from, and I was like, I don't know, Barcelona, I think, but Barcelona was where I was at, so I probably seemed really suspicious. I was like, I don't care, like this isn't where I'm going to, so this is just a stop. And then he asked me how much money I was carrying.
Big gun like
Well, I mean, he was the police guy, so
yeah.
I guess if I had said, you know, $100,000, he would have been real suspicious, but
It was last summer, and every stop on the way home, I got stopped for some reason. Like, it wasn't anything bad or anything. It was really annoying, and also quite stressful, because we were like 20 minutes late to our flight.
yeah. One time we were cutting it real close, and then they like pulled me to the side for like an extra optional scan or something. Like I was one of 3 people, and it's like, we're gonna miss our flight because of this.
Yeah, no.
We didn't, but I was worried about it.
No, we were, no, we got off in, I think it was in Paris on the flight back, and there was the massive line It took us like hours to get through. We were already
Oh, yeah.
late for
Oh,
our flight.
yeah.
And then we had to take a shuttle across the entire airport.
Yeah.
To get to a totally different section.
Yeah. Airports are stressful.
And once we got there, it was like 30 minutes after our flight should have probably already taken off. It was still there.
Yeah, it was probably delayed too.
I got it wrong. Why did it say that's what?
And then I got my searched.
You got it?
And then I got random searched. Airport in Paris. After sitting for like 2 hours and like briefly.
Okay, this is the same thing.
You're lucky I missed.
Did I just round it wrong? I wonder what the actual answer is.
Now look, here's your.
And on the
Okay, so
flight
you didn't put
back,
pi
we
in.
had to stop in
Mm-mm,
Paris.
but then I put pi in after.
Okay, yeah, I understand. But so this is supposed to be your r squared.
Yeah. Oh, I didn't square it.
Yeah, you didn't square it.
Okay.
If you squared it, it would just remove that square root, and then it would look like that.
Okay. Okay, that makes some sense.
How many have you been on?
Wait, what? No, I've only been able to see it over the country.
Like,
Japanese, my own personal.
Do you remember how long your flight was back to the States?
It was like 9 hours.
Ours was 8, and it was.
Yeah, it was 8 or 9 hours. I don't remember.
It wasn't too bad coming back, but going that way was.
I hadn't slept
It felt
that
like
night
2 days.
because, our flight from, I think it was Rome, left at 3 in the morning.
Yeah.
And my luck with sleeping on planes is terrible. So that was very pleasant.
Yeah. I mean, you're only 15,000 feet in the air, you know.
No, I don't have any issues with the height. It's just that they're so cramped.
Oh.
Stroopwafels? No. But we did get a paint rectangle. When we say a paint rectangle, it's just a little teeny little ciabatta.
what is a pain rectangle?
Well, Oliver, we were on a French airline. So a pain rectangle is a rectangle of bread. Nope.
I imagine like a shard of glass.
Did you know that even though you only have 206 bones as an adult, you have over 6
Alex.
Well, I know a guy who can help you with that. And get all your bones back. You know, he's gonna help you get your bones back. No, he's gonna help you unfuse your bones. You should do an advertisement that I saw in the Fayetteville airport. That guy.
Baseball.
He's a sports medic.
Sports medic.
Yep.
Surgery.